All right, we're going to finish up your fossil fuel notes today. So we're doing 13, 14, and 15, and then we will be done with our fossil fuel notes, and we'll be ready for our open note quiz. All right, so we are looking back at coal one more time, and I'm going to play this video for you right now.
Coal. Coal is a black or dark brown combustible rock made primarily of carbon. It was formed millions of years ago when ferns, plants, and trees died and fell into swamps. The swamp conditions prevented the organisms from decaying completely, and after millions of years of intense heat and pressure, coal was formed. Coal is classified into four main types or ranks based on carbon and heat content: lignite, subbituminous, bituminous, anthracite. The general rule is that the higher the grade of coal, the cleaner it burns and the more versatile its uses. Coal is extracted from the earth through underground mining or surface mining. The choice of mining method is largely determined by the geology of the coal deposit and its distance from the surface. Underground mining currently accounts for a larger share of world coal production than surface mining. Coal can be burned for heating or to produce electricity. To convert thermal coal to electricity, it is first milled to a fine powder, which increases the surface area and allows it to burn more quickly. The hot gases and heat energy produced from combustion converts water into steam to run a turbine and generator. High-quality coal is also a useful raw material. For example, it can be converted to coke for steelmaking. Coal can also be converted to liquid or synthetic gas by advanced chemical processes, making it a possible but costly replacement for natural gas or liquid fuels for transportation. Coal is a highly abundant and cheap energy resource. Coal has powered the industrialization of many nations over history and continues to today. It is a big player in today's energy system, providing 40% of the world's electricity. One major concern with coal is the mining practices used to extract the resource. Ecological impacts and human safety issues, both for workers and neighboring communities, are growing concerns for the industry. Coal is the most CO2-intensive fossil fuel when combusted because it is composed largely of carbon. Coal also contains other elements that cause pollution problems, including sulfur, nitrogen, mercury, and heavy metals. SOx is a leading cause of acid rain, and NOx emissions contribute to smog. In addition, particulates from coal combustion can be harmful to human health. Concerns about climate change from greenhouse gas emissions have put a spotlight on coal plants and have prompted the development of clean coal technologies like carbon capture and storage. That's coal.
Okay, what I really want you guys to focus on, I know that video gave you a whole lot of information, and a lot of it was really good background information for you to have on coal. But what I really want you, if you don't remember anything from this video, I want you to at least remember this part right here about the plants.
Plants and trees died and fell into swamps. The swamp conditions.
Okay, so there was a period of time, millions and millions and millions of years ago, that a lot of the earth was covered by these swamps, right? And so in those swamps, there was a little bit of water, but mostly a lot of plant life. And when those plants died, they would sink to the bottom of the swamp and they would become buried in layers of sediment.
Prevented the organisms from decaying completely, and after millions of years of intense heat and pressure.
So those plants turned over millions of years, heat and pressure, heat from inside the earth, pressure from all of the layers pushing down, caused those plant remains, that organic matter, those remains of dead plants from the swamps, to change into something that we can use, something called coal.
Coal was formed. Coal is classified.
Okay, so if you don't remember anything else from that video, at least remember that plants are the driving force behind, or are the base ingredient for coal. All right, oops, didn't mean to do that. So we're going to just type a few words about how coal is formed. Whoops, cannot get it to cooperate. Okay, let me zoom in. And if I'm typing too quickly, of course, you can pause. Okay, so how coal is formed. So we're going to say millions of years ago, Earth was covered in swamps. And I'm putting it in all caps because it's important. Ancient plants. And we're going to put plants in all caps. Ancient plants died and became buried. Heat and pressure over time, millions of years, changed the plants into coal. And we're going to make plants all caps again because that's what I want you guys. That's the biggest thing that you're going to be quizzed over. That's the biggest thing that's going to come up for you. So your big takeaway from this whole unit on fossil fuels needs to be that plants go with coal and ocean organisms go with oil and natural gas. And I know I've said that about 1,000 times already. And it's because that's the most important thing about this unit is that you associate plants with coal and oil and natural gas with oceans. Okay. And then here's this helpful little thing. It's showing you the millions of years ago. It's showing you the plants. They die and become buried. Heat and pressure turn them into coal. Okay. And so pause here. I know that was a lot of typing just now. So pause here to fill those in. And then we'll go to 14. Okay. So now we are comparing the three fossil fuels. So we're comparing oil, coal, and natural gas. Okay, so I'm just gonna start here and work my way over. So a gas would be natural gas, liquid would be the oil, solid would be coal. I know I'm going pretty fast here. Remember, you can always pause this video. Black or dark in color, that could describe oil or coal. Formed where there were swamps. So swamps is my keyword, and that only belongs under coal. Found near gas would be oil. Remember, gas and oil are located usually very close to each other because they were both formed from ocean organisms. So formed from where there were oceans would be both oil and natural gas. So that's going to go here. Made from the remains of tiny ocean organisms also describes both oil and natural gas. So that would also go in the middle. Not a liquid would describe gas and coal. Found near oil would describe natural gas. Forms from heat and pressure. Now, they all form from heat and pressure, so that's going right in the center of my Venn diagram. So they all three form from heat and pressure. Extreme heat and pressure, remember that has to do with natural gas. Made from the remains of plants would be coal. Millions of years to form, that describes all three of them. They're all fossil fuels, so that goes in the middle as well. And then no definite shape would be natural gas because it's a gas. Remember from states of matter that gases do not have a definite shape. All right, and that's it for that one. And then we just have 15. So here, now we're going to compare fossil fuels and sedimentary rocks. So this is another thing that you will be asked to do quite often, is compare sedimentary rocks to fossil fuels. And so we'll put their similarities in the middle, and then we'll put their differences under each title. So cementation and compaction goes more under sedimentary rocks because those are the two processes that really cause those sedimentary rocks to get squished down, squeezed together, and stuck together. Now, heat and pressure, remember, is a major similarity between fossil fuels and sedimentary rocks. Both of these resources require heat and pressure to be able to form. Fossils trapped in layers. So fossils refers to the organisms that become hard, and then now we can see them as imprints or fossilized bones. So remember, fossil fuels are made from organic matter, are made from those organisms that get trapped. But the difference is fossils in sedimentary rocks are the hardened remains of those organisms, whereas fossil fuels, the organisms actually change to become a fossil fuel. Made from dead organisms would be fossil fuels. Layers of sediment is required for both. Millions of years would be both. They both take millions of years to form. They both require layers of sediment to form. Used as an energy source. So this would only be fossil fuels. We cannot burn sedimentary rocks for energy. And made from sediment would be sedimentary rocks. So there you go. That's all for today's notes. Now you are done with your fossil fuels notes. Make sure you have them all complete. Make sure you have all of these complete because you will need them for your open note quiz.